A company gave an AI agent the task: research our 5 main competitors and produce a one-page briefing. The agent searched the web, read 10 articles, pulled financial data, compared product features, and wrote the report. No human touched it. That's not a chatbot. That's an agent. In 5 minutes, you'll understand exactly what that means. What's the difference between a chatbot and an agent? A chatbot waits for your question, generates a response, and stops. It has one turn. An agent has a goal, a set of tools, and a loop. It reasons about what to do next, takes an action, observes the result, and keeps going until the task is complete or it needs your input. The key word is autonomy. An agent makes decisions and takes actions without being told exactly what to do at each step. So what exactly is an AI agent? An AI agent is a large language model connected to tools, search, code execution, APIs, databases, file systems, that runs in a loop to complete a multi-step task. The LLM is the brain. It reasons about what to do. The tools are the hands. They let it take action in the world. The loop is what makes it autonomous. It keeps reasoning and acting until the job is done. Here's the agent loop, also called the React pattern. Step 1. Perceive. The agent reads the task and any available context. Step 2. Plan. It reasons about what action to take next. Step 3. Act. It calls a tool, a web search, a calculator, a code interpreter, an API. Step 4. Observe. It reads the result of that action. Step 5. Repeat. Plan the next action based on what it just learned. This loop continues until the agent decides the task is complete and produces a final output. Tools are what make agents useful. Without tools, an agent is just a chatbot that thinks in loops. With tools, it can search the web, run code, send emails, call APIs, read files, write to databases. The agent decides which tool to use and when. That's the reasoning happening inside the LLM. MCP, Model Context Protocol, is a standard for connecting LLMs to tools consistently. More on that in the next episode. Here's a concrete example. Task: research our competitors and write a briefing. The agent loop. First, it searches for the top 5 competitors. Then it reads each company's website and recent news. Then it pulls pricing data. Then it compares features. Then it writes a structured one-page briefing. Each of those steps is a separate tool call. The agent decides the order. A human didn't specify each step, just the goal. That's what makes it agentic. For more complex tasks, you can use multiple agents working together. A planner agent breaks the goal into subtasks. Specialist agents handle each subtask in parallel. A synthesis agent combines the outputs. This is how companies are now running entire workflows with AI, research, writing, code review, quality checking, each handled by a different agent, coordinated by an orchestrator. This is called multi-agent architecture, and it's how the most ambitious AI applications are being built today. When should you trust an agent? And when shouldn't you? Trust agents for well-defined tasks with clear goals and reversible actions. Research, drafting, analysis, code generation, these are good agent tasks. Be careful with agents that take irreversible actions, sending emails, deleting files, making purchases, deploying code. Always build in a human checkpoint before consequential actions. The principle is, the higher the stakes, the more human oversight you need. Agents are powerful assistants. They're not yet reliable autonomous decision makers. Here's the one thing to remember. An AI agent is an LLM with tools and a loop. The LLM reasons. The tools act. The loop keeps going until done. What makes it powerful is that you give it a goal, not a script. What makes it dangerous is the same thing. Give agents clear goals, appropriate tools, and human checkpoints for anything consequential. That's the whole framework. That's AI agents explained in 5 minutes. Subscribe to AI SkillSprint for one AI concept, explained simply every week. Next, what's MCP, the Model Context Protocol, and why is it changing how agents connect to the world?